All right, so let's start with our Krebs cycle, also known as our citric acid cycle. So this pyruvate has come to us down a pathway from glycolysis. It is transferred to the mitochondria. That method isn't important at the moment in our case, but the pyruvate is broken down in the first step into something called acetyl-CoA. And you'll notice that we're going from a 3-carbon molecule to a 2-carbon molecule. And that 2-carbon molecule is then going to enter our Krebs cycle. Right? Before we get to that Krebs cycle, we have this little mini step out here. And this process of breaking pyruvate into acetyl-CoA is going to release carbon dioxide as a waste product. And it's also going to take and turn NAD positive. It's going to reduce NAD positive, and it's going to make our first electron carrier, or NADH. Right, so that electron carrier, NADH, is going to go off to the electron transport chain, like we said on our previous overview. All right, acetyl-CoA enters the Krebs cycle, the citric acid cycle, and is going to be joined with a 4-carbon molecule. And some of these molecules I'm not naming. They have names. We're not going to worry about what they are at the moment. But when it joins to that, it's going to become a 6-carbon molecule called citrate, hence the name the citric acid cycle. So now we have our 6-carbon molecule. Here it's our citrate. And citrate is going to go through a series of decomposition reactions. Each one of those decomposition reactions is going to pull off carbon dioxide and energy. So just to point out where we have added 2 carbons to this, so we need to remove 2 more. And in that process of removing those carbons, we are going to see the production of quite a few electron carriers. So our first carbon dioxide is removed, leaving us with a 5-carbon molecule that, again, you don't need to know the name of. But the process of making this 5-carbon molecule is going to leave carbon dioxide that is going to be exhaled. And it's also going to take and reduce NAD+, turning it into our electron carrier, NADH. That NADH is going to go off to the electron transport chain. We're going to see another set of decomposition where we get down to a 4-carbon molecule, 1, 2, 3, 4 carbons. And again, we're going to see the removal of a carbon dioxide that's going to be given off as waste. And we're going to see an NAD be reduced to form our electron carrier NADH. And as you can guess, that NADH is going to go off to the electron transport chain. Our 4-carbon molecule is going to undergo a couple of changes as it moves around the rest of the circle, but we're not going to remove any more carbons. We've already taken off our 2 carbon dioxides in decomposition. Now we're just going to strip some of the extra energy that is in here. And one of the things that's going to happen is we're going to see the making of ATP, a really small amount of ATP. If you remember, we had a phosphate on our, no, that's not accurate, but we're going to see a new electron carrier called FAD plus come in, and this FAD plus is going to be, again, reduced to make an electron carrier called FADH. And this 4-carbon molecule, as it changes form, is going to be moving around back to the beginning, and there's just a little bit more energy left here. And that is going to be removed as we oxidize our last NAD to form our last electron carrier. And that electron carrier is going to go, again, off to the electron transport chain. So you don't need to know a lot of the details of this. What I do want you to recognize is that as we decompose our pyruvate and the carbon is removed, that carbon dioxide is released. The carbon is removed in the form of carbon dioxide. It's released as a waste product and it's breathed out. This happens 3 times for the 3 pyruvate molecule that we're coming in with here. So pyruvate's entering with 3. 1 is released for acetyl-CoA. That becomes citrate. Another carbon dioxide is released. We're down to a 5-carbon molecule. Another carbon dioxide is released. The other thing that's really important that's happening here is the production of all of these electron carriers. So NADH is produced 1, 2, 3, 4, and FADH2 is also produced. And so for one pyruvate, we have made our 3CO2, which is waste, breathed out. We have made 1, 2, 3, 4 NADHs. We have made 1 FADH2. And we have made 1 ATP. Now, thinking back about this pyruvate, one pyruvate is only equal to half of a glucose. So the reality is all of this has to be multiplied by 2 if we're talking about a glucose molecule. So glucose times 2 is going to mean that we have 6 carbon dioxides as wastes. We have 8 NADH, we have 2 FADH2, and 2 ATPs. So we can pop back over here to our overview for just a second, and we can put in a few numbers here. So we can put down 2 ATP here. We can put down 8 NADH, 2 FADH2, and then we can add in our 2 NADH up to the top there. So we can now go on to the electron transport chain. One last aside, this ATP right here is going to be, again, use by the cell. So far between glycolysis and the Krebs cycle, we've made a total of 4 ATP that are going to be usable by the cell. All right. One last thing, and that's just to remind you that the Krebs cycle is occurring in the matrix of the mitochondria. So when you think about your mitochondria, if this is our mitochondrial drawing, the matrix is, I'm going to draw it, highlight it in blue here. The matrix is this protein-rich mixture on the inside of our mitochondria. And this is where all of this cycle is taking place.